We are talking about probabilities, and when we talk about probabilities, we must first talk about what we consider possible outcomes. When we're looking at possible outcomes, these are the things that when you're talking about something happening, an event, what could be an outcome? And all these possible outcomes make up what is called a sample space. So the sample space is all possible outcomes. So it's all the possible outcomes of a given event. So we're looking at what could happen. For example, if I flip a single coin, what are my possible outcomes? Well, flipping a single coin, I could either get a head or I could get a tail. Those are my two outcomes, possible outcomes. If I roll a fair six-sided die, then my possible outcomes would be 1, 2, 3, 4, 5, and 6. So it's your sample space is actually a list of all these possible outcomes. When we're looking at these possible outcomes and this sample space, sometimes we need to create what is considered a tree diagram so that we can find out all of your possible outcomes that you could have. For example, let's say I have a three-sided die that has the numbers 1, 2, and 3 on it, and I want to roll 3 times. Okay. We can go through there and list it out, but I'm going to do what is considered a tree diagram. So on my first roll, I could get a 1, I could get a 2, or I could get a 3. So this is the first roll. On my second roll, if I rolled a 1, I could get a 1, I could get a 2, or I could get a 3. If I rolled a 2, I could get a 1, a 2, or a 3. If I got a 3, I could get a 1, a 2, or a 3. That's my second roll. Then on the third roll, for each one of these branches, I could still get a 1, a 2, or a 3. 1, 2, or 3. 1, 2, or 3. 1, 2, 3. 1, 2, 3. So if you'll notice, I don't have just 3 options anymore. I actually am going to end up with a total of 27 different possible outcomes. Because if I look at my rolls, I could get a 1 here, and off of that 1, I have 3 different possibilities here. I could get a 1, 2, or 3. So I can get a 1, or I could get a 1 and a 2, or I could get a 1 and a 3. But then off of the 1, 1, I can get a 1, 2, or 3. So technically, I would have this for each one of them. Okay? So I would end up with a 1, 2, 3, 1, 2, 3. So notice now I'm kind of coming back through here and plugging in. This is just if I roll the 1 on the first time. Then if I roll a 2 on the first time, I would end up with, not a 3 there, with all of these different possibilities, because I could end up with a 1, a 2, or a 3 as my second roll. And then on my third roll, I could end up with a 1, 2, or 3. 1, 2, or 3. 1, 2, or 3. And then the same thing happens with my 3s. So I end up with a 3, and then on my second roll, I could have a 1, a 2, or 3. And then on my third roll, I could end up with a 1, 2, or 3. And now I know that you're saying that some of these may be the exact same, because let's see here, I have a 3, a 1, and a 2, I have a 3, 2, and a 1, but notice that because I wrote them out as different colors, technically they're not exactly the same. You got those numbers on different rolls. So whenever we're rolling things 3 times or picking things at different times, those different times actually count as different outcomes. So the order that you pick things would matter when you are selecting multiple items. So all of this right here, where I have everything written out down here, total of 27 different possibilities, is my sample space. And so that's the advantage of doing a tree diagram when you have multiple objects that you're selecting. Okay? So what I want you to do is practice sample spaces and let me know if you have any questions.